Welcome to my presentation. Today, I will talk about USB snooping made easy, crosstalk leakage attacks on USB hubs. My name is Yang Su. This is a joint work with Daniel Genkin, Damith Ranasinghe, and Yuval Yarom. This is what the back of our PC looked like. Many years ago, you may find a serial port, parallel port, keyboard and mouse connectors, audio jacks, and also the game controller connectors. For the latest PC, they are all replaced by USBs. Since it has been introduced in mid-1990s, USB experienced several revisions. Today, we are mainly talking about the first three out of them. You may ask yourself, where can I find such old devices? The truth is that USB 2 is still quite common today. For some devices, if we take a closer look, for example, human input devices, they are still using the earliest version, USB 1.0, because they don't need such high data transfer rate. We have been talking about the history of USB. Obviously, USB do carry some sensitive information. For example, passwords. So let's talk about the security features of USB. Well, the truth is so sad, because USB don't have any security at all, except one thing. USB do have some basic routing mechanism that makes not all devices in the network can see all traffic. To understand why, let's talk about the USB topology. First of all, we have a host machine, which contains USB root hub, which is the root of the whole USB tree network. And then we have the USB hub, which allows us to connect multiple devices into the network, including webcam, printer, USB storage, mouse, and the keyboards, even the USB-powered lamp. The downstream data in USB network is broadcasted. For example, we got a PDF stored in the USB memory. The PDF firstly arrives USB root hub and then forwarded to the USB hub. At this point, the PDF file is just broadcasted to all devices in the USB network, particularly USB storage. Even the USB-powered lamp can get the same PDF. Let's consider that if the lamp is malicious, that means the attacker can also get my PDF. However, the upstream data is unicast. For example, I press one key on my keyboard. The key press information sent from the keyboard to the USB hub, and then after this point, it directly go to the host machine. USB devices cannot communicate between themselves. Therefore, the attacker has no idea which key I just pressed. In this paper, we ask the following question: how can we mount off-path attack on USB devices? In this paper, we demonstrate attacks on both human input devices and to some extent for USB storage. In order to do that, we capture the analog crosstalk leakage signal from the USB hub, and then we can figure out what happens on the other port on the same USB hub. We tested dozens of USB hubs, majority of them showing some leakage. One thing that makes the situation even worse is that the crosstalk leakage not only happens on data lines, but also on power lines. This situation bypasses some existing hardware countermeasures. For example, the power-only USB cables. Now let's look at a demo where and how can we observe the crosstalk leakage? What I'm doing on this table is exactly as shown on the screen. First of all, we got a host machine, which is connected to a 4-port USB hub. On each port, we got 4 pins. 2 of them are power LAN, 2 of them are data LAN. As you can see, here's a blue cable, which is connected to a USB keyboard. What you cannot see is inside this blue cable, there are 4 strands, which provides power to the keyboard and retrieves data back to the host machine. Now, we take 1 data LAN and 1 ground LAN of the blue cable in order to show the traffic between the keyboard and the host machine, and plug them to the oscilloscope. Next to the keyboard, we got a red cable, which contains a data LAN and a ground LAN. We also connect it to the oscilloscope. Now, let's switch to the scope screen. As you can see, on the top is a digital traffic signal in the blue cable. At the bottom, the red waveform is a leakage signal captured from the port that's next to the keyboard. The 2 signals are correlated. To highlight that, let's move the leakage waveform upward. As you can see, the correlation is clear. Therefore, based on the leakage waveform, we can reproduce the digital signal between the keyboard and the host machine after some simple signal processing steps. You may be wondering what happens on other USB hubs rather than one I took with me. We tested dozens of USB hubs. Here are 4 examples out of them, including external hubs and internal hubs inside the brand name computers. They are all showing clear correlation between the leakage waveform and the digital traffic. Therefore, we can reproduce the information based on the leakage. After seeing the leakage waveform, you may be wondering how it happens. For most USB hubs, they use single-chip solution. Ideally, each port on the same chip should be isolated from other ports. However, due to manufacturing imperfections, there exists a parasitic capacitance between 2 USB ports. Such parasitic capacitance, which is shown in red symbol in this diagram, create a linkage between 2 adjacent USB ports. If we have a digital signal going from one port, it could induce a leakage waveform on the other port through the capacitance linkage. Now, let's talk about what can we do with a leakage signal besides attacking the USB keyboard. In this example, we take the leakage signal from an external USB hub, which have a USB fingerprint scanner connected to it. Therefore, we can steal users' fingerprint information from the leaky hub. In addition to that, in this example, we attack the internal hub inside this laptop, which have a credit card reader connected to it. If you analyze the leakage signal, all of my credit card details will be reviewed and made available to you. You may think it is completely impractical for someone just bring this oscilloscope with strange wires and plug into our our computers. However, people do buy cheap gadgets of eBay and plug them to their own computer. In this example, we just had the oscilloscope inside this USB-powered lamp. Let's see a live demo. What I got here is a USB keyboard. It is connected to my host machine through a leaky USB hub. On the same hub, there is a malicious USB lamp connected. Therefore, the lamp may exfiltrate the key press events and wirelessly send it to the attacker's laptop. Let's switch to the attacker's laptop and see what happens. Now, user want to type something. For example, use a conference, the name of our conference. As you can see, the key press event on this keyboard to this host machine has been captured by this malicious USB lamp and then wirelessly transmitted and displayed on attacker's laptop. Up to now, we are talking about attacking USB 1. Now, let's think about attacking USB 2. Different from USB 1, USB 2 running at a greater speed, which is 480 megabit per second compared to 1.5 megabit per second for USB 1.0. Meanwhile, the USB 2 is also running at a lower logic level, which is only 0.3 watts compared to 3.3 watts for USB 1. Therefore, in order to capture such high speed and weak leakage signal, we need more accurate equipment. For example, this 6 gigahertz oscilloscope with active probes. In this example, we capture the leakage signal from a leaky hub that have a USB 2.0 memory stick plugged in. On the top, the yellow curve shows the traffic between the laptop and the USB 2.0 memory stick. At the bottom, the blue line shows the leakage signal captured from another port adjacent to the USB memory stick. You can see the two signals are correlated. Therefore, we can figure out the information being transmitted between the computer and the USB memory stick based on the leakage waveform. There are some existing hardware countermeasures. For example, this tiny thing, which is a data line isolator, which basically cut off the USB data line, but let the USB power line goes through. It allows us to use USB as a power source to power up some devices like USB-powered lamp. In this example, let's have a look how it works schematically. Remember the red cable we used to capture the data line leakage in the previous demonstration. Now, we have a data line isolator inserted onto the red cable. It just disconnects data line, which means we cannot monitor the crosstalk leakage on the data line anymore. But it leaves the power line intact. We can still use the power line as a media to capture the crosstalk leakage. You may be wondering how often the power line crosstalk leakage happens. Again, we tested dozens of USB hubs. There are 4 examples, including external USB hubs and internal USB hubs in brand name computers. As you can see, the top yellow curve is the digital traffic between the USB keyboard and the host machine. At the bottom, the blue curve shows the crosstalk on the power line. Whenever there's a transition on the traffic line logic level, it induces one spike on the power line. The 2 signals are closely correlated. Therefore, from the power line crosstalk leakage, we can figure out what happens on the traffic line. We have seen the crosstalk leakage is widespread. Let's consider some countermeasures. First thing, but most important, please do not plug anything that you don't trust to your USB port, because there are so many malicious devices exist. And then, in addition to the data line isolator, we may add a voltage regulator to the power line, which largely reduces the power line crosstalk leakage. In this picture, it shows what the voltage regulator looks like. On the diagram left-hand side, the black trace shows the power line before entering the voltage regulator. You can see there's many crosstalk spikes. After the voltage regulator, most of them has been removed, as shown on the orange trace. Finally, we can always add encryptions to the USB network, which requires to completely redefine the USB ecosystem, but it could effectively resist USB snooping attacks, including our crosstalk leakage attack. Now, let's talk about limitation and future work. Our attack only works on USB 1 and to some extent on USB 2.0. It doesn't work on USB 3 or Type-C because there are some extra data pins has been added, which makes it difficult to analyze the crosstalk leakage on USB 3. In addition, USB 3 runs at extremely high speed, which requires sophisticated equipment to capture the crosstalk leakage. Although we use USB as an example in this project, but we believe the crosstalk leakage not only happens on USB, but also makes other unencrypted buses vulnerable. That's all my talk. Thanks. Now I take questions.
If you have questions, please step up to the microphone, state your name and affiliation, and fire away.
Martin Grode, Ruhr University Bochum. I would like to know, you mentioned like the injection is happening to the other port, so that's the reason why you can actually see the leakage of the data. So my question is, why is it not send it twice when the leakage is injection into the other port? Why doesn't it get sent to the computer?
You mean why the normal USB communication not affected by the crosstalk? Is that your meaning?
No, I think you have the first port, which is is the one which transmitting the packets to the computer, right? Because from your keyboard it gets to the hub and then to the computer. So when you when you make a keystroke, the information is leaked to the other port.
You mean why other devices which connected to the same USB hub cannot get the information from the keyboard?
No. Okay. Third time. If the leakage is injected into the another port, so you can see it on your attacking device.
Yeah, we can see it on the oscilloscope.
Yeah. Why is it not then send it again from this port to the computer? Okay. Thank you very much.
All right.
So for the audience, the answer to the question was that the voltage is too low and therefore the signal doesn't get sent twice. Is that a question?
Hi, Boke, UBC. Well done, you did a great job. I was just wondering generally, do you have a survey of people that may have been attacked as a result of using USB 1.0 and stuff like that? Like just a general idea of anybody being attacked as a result of using past versions of USB?
Sorry, I cannot hear you clearly due to the echo.
Okay. The question is, do you have like a rough idea?
Can I come here and?
Okay.
Okay.
Do you have a rough idea
of
anyone that has been attacked, or like any attack that has been made as a result of using past versions of USB?
As far as I understand this, we are the first group who discovered this crosstalk leakage on USB hub.
Okay. Okay. Thank you.
Are there any further questions? There's one coming up there.
Hi, this is Lena from UBC. So just a follow-up question to that. So I think what she wants to ask is more about like the percentage of people who are using USB 1.0 now. So it's kind of like personally, I will feel like more people are like transferred to USB 2 and 3, and 1 is currently not that used many times or more frequently now by people. So like, what's your understandings on like the importance of this attack for USB 1.0? Like, is it still very critical for people to pay attention to and something like that? Thank you.
I think the USB 1 is still widely used. For example, most of keyboards and mouse are still using USB 1, including OEM products and retail models. They are still USB 1.
Okay, thank you. And another follow-up question. So you also mentioned like for USB 2.0, like to some extent your attacks works. I'm just curious, is there any way that we can tell like what USB things that we use will be attacked? Like what kind of manufacturers was the USB, the brand of the USB that will be safe and what is not? It's just like I'm curious about that.
Yeah, the attack works on USB hubs rather than USB devices. We tested dozens of USB hubs that almost 30% of them are vulnerable to the crosstalk leakage attack.
Okay, thank you.
Thank you.
There's more questions coming.
Okay,
let's take those two and then we're officially out of time.
Yeah. Thanks for the presentation. I'm Shinjo from TU Berlin. And the first question is that, is this problem mitigatable by modifying the firmware of the USB hub, or is the redesign of the silicon is required?
We don't need any hardware modification, just commercial hubs that have crosstalk leakage.
Where I meant that for manufacturer of the commercial USB hubs, do they need to fix the...
to fix this issue?
Yeah.
I think the problem happens on hardware level. Firmware probably cannot solve the problem. They need to redesign the chip and to remove some parasitic capacitance between two channels.
Okay. And when
that was your question. Let's move over to Anil, and then we have to move on to the other talk.
All right. So first, great work on the live demo. It's always risky business, and that was great to see it working live. My question is related to using basically USB hubs in Cascade, which is often done. So plugging a USB hub into another one. Can you still observe crosstalk in those settings? Have you tried it?
The crosstalk is basically happens on the same hub.
Right.
The port next to each other.
Right.
For cascaded, we need to consider each hub. Consider the crosstalk happens on the same hub to adjacent ports. It probably doesn't leak between different hierarchies.
Okay, so that would be a potential countermeasure then. If you don't trust one device, you could put it on its own hub compared to the other ones.
Have a hub that only plugs the risky devices.
Thank you very much.
Thank you.
All right, let's thank the speaker one more time.